So if you have a degree in electrical or electronics engineering, and if you are in a job market, you need to improve your CV to show some of the skills, and those skills will increase your chance to get hired in the job market. So what you need to do is to show your hands-on experience in some of those skills, and in this video I will talk about those skills and how you can acquire it. One of the things you can do is follow this complete tutorial list that I will talk about, and this is just one of the things that you need to do is, and the key thing is you need to get into one of these streams and follow it all way to get an hands-on experience. So this particular video will talk about acquiring the hands-on experience in designing a small circuit using schematic capture, doing some simple simulation, and then actually designing it, testing the board, and then finally showing that design circuit is doing some actual work. So what you need to do is either purchase, download, or there are few free versions available, and to design a schematic and to simulate it and then actually build the board. So the first tool is called Allegro and OrCAD combination. It's a very high-end tool that is used to design complex PCBs like the one that is used in cell phones, or a PCB for maybe a laptop or a server, a complex. They are very high-end tools, so they they are very good if the PCB has a very dense routing. So Allegro and OrCAD is also very expensive. So unless you have an access to them in a very good industry, if you are doing your, for example, your summer training or something, it's very hard to get an access to it. But if you can get, I would think this is the best tool you can do. There are two less expensive versions. One is one less expensive tools. One is called Altium. It's very popular, but it's not all. It's still not that expensive as Allegro or OrCAD, but it's still reasonably expensive. Third one is Eagle software, and there are some free versions of it which probably have some limitations in the complexity of the board, so you can try this thing. But the one that I am going to tell you about is called a KiCAD. So what you need to do is, it's called KiCAD. KiCAD, it's a free and open source. It's a free and open source tool that you can download. You can actually download the whole source code and build it. There is the Linux version and also a Windows version. You can download the exe file or the binary file, download it in your computer and start playing with it. So there are 3 or 4 steps of it doing it. The first step, in your mind, first you will bring a keep a very simple circuit that you want to design. For example, it can be as simple as uh, glowing a bulb when there's a dark, basically a photoresistor, photosensor, and the photosensor driving a maybe bulb, something similar, simple like that. It has very few simple components. So the first thing you will do is you will draw the schematic of this circuit, and then once you have done the mastery on schematics, then you need to move on to design the actual PCB of it. So in the PCB it takes some time to get a hang of it. You follow the tutorial. Whenever you are stuck with it, you can ask the question in the comment section and I can help, or someone else can help, or you can ask these questions in the forum. But eventually when you have your PCB designed, you need to generate a Gerber and send the Gerber files to a PCB manufacturer. And in the parallel, probably you should also learn about soldering thing. So basically when you have few components, how to solder it. So spend some money, buy a soldering iron, buy some components, start practicing soldering. If it's a little complicated board, you can give it to an assembly house who can assemble the board. When the board comes in, you should be ready to with few meters, power supplies to test the board. So buy a multimeter. Eventually, if it's complicated, you may also need to buy a oscilloscope. but with simple circuits a multimeter could be good enough. Then the circuit needs to do this function. If it's a little more complicated, for example, it has op amps and few more things, you will also need to do the simulation things to make sure that it does the you get the required functionality. So once you have the hands on some simple circuits, then you need to move on to do a little more complicated circuit, which does a little bit of more complicated functions, some IoT functions, some sensors, and sending the signals over a Bluetooth or something like that. You can make use of the existing modules to do those things like that. So if you have that kind of experience, if you have actually worked on the board, in the interview you can speak with more confidence. You can speak whatever you speak will automatically reflect your confidence because you have actually done the work on it. And then if your confidence is reflected in whatever you speak, the employer will be more willing to hire you. And if you already have some experience, you will be able to get a better job of that you want. So that's all about designing some simple circuits and getting experience on this, hands-on on those tools. But there are other things that you can do. For example, you can have experience in a Verilog or VHDL, and then hands-on experience on some FPGA thing. So for that you will have a separate video and a separate list of the things to do. So keep following this whole thing, and then we hope that it's going to help you in getting a good or a better job.